So, has your business ever dealt with a bottleneck caused by your inability to mechanically check parts quickly? Have you ever missed a shipment deadline because your coordinate measuring machine couldn't measure a production batch in a timely manner? Could you manufacture more parts if you only had the ability to inspect them faster? Well, if you answered yes to one or more of those questions, most likely your bottleneck is the speed with which you can measure using traditional touch probe methods on a CMM. So although CMM touch probing is or can be very, very accurate, it is also rather slow. Then that is why more and more companies are turning to laser scanning technologies for 3D part inspection. Our next guest is Alex Lucas of Nikon Metrology, here to discuss some of the advancements in laser scanning in what it offers over touch probing. Hi, Alex.
Hi, Dirk. How's it going?
Oh, pretty good. So just so we can set this up ahead of time, obviously we're going to be talking about laser scanning, and obviously we're going to be talking about probably Nikon equipment. But Nikon itself actually makes touch probing as well, right? I mean, you guys do touch probe CMMs as well as laser scanning CMMs. Is that right?
Absolutely. One of the things that we've really wanted to bring to the market is the capability of having a multi-sensor inspection system. So what a CMM obviously offers is a history of being able to use a touch trigger probe or even an analog scanning probe to be able to inspect a lot of data very accurately. But something that we've introduced, and really over the last few decades, come through a couple different generations of laser scanners that are starting to narrow the gap with what you can analyze or measure with a touch probe.
Well, yeah, I mean, I was going to say, I mean, I know that one reason some shops didn't use laser scanners in the past is because, you know, traditionally, I'm guessing, I'm talking maybe 10 years ago, you tell me, is that the accuracy just wasn't there. And so if you wanted accuracy, you really had to go with like a touch probe. Are laser scanners getting close to competing with traditional touch probe CMMs in terms of accuracy?
Absolutely. The nice thing about the laser scanning, obviously with my own biased view being with Nikon, is what we've been able to do is introduce the optics that can match with what we can do from an acquisition standpoint. So historically, we can always go through and collect the point cloud information, but when you combine that with obviously the same or similar type of optics that you would find inside of a Nikon DSLR camera, you're going to get very superior results when it comes to the accuracy of that scan data. And obviously that scan data just trickles down into what you can actually inspect. And then when you look at the correlation between laser scan results and tactile results in a CMM, they're starting to get within 5–10% of your overall tolerance zone. So more than comfortable for most customers to make the leap to laser scanning.
And so have companies like Nikon and the others, obviously Nikon isn't the only company that does any kind of laser scanning. Have all of you guys seen the market kind of evolving over time, where you're seeing more and more shops that might have traditionally gone with a CMM now actually saying, okay, well, I guess it's time now to get a scanner?
Absolutely. I think one of the things, like I'd mentioned, the multi-sensor inspection methodology, being able to use both a laser scanner and a touch probe for a given part is a critical thing. I think for when we show you the webinar this coming Tuesday, we're going to focus on the laser scanner, but one of the things that's been critical to us in listening to customer demands is the fact that they still have certain features and certain things that they want to inspect with a touch probe. For people that are familiar with checking parts in a CMM, nothing is more critical than setting the correct alignment frame and getting your datum structure measured and tied in as accurately as possible. And that's something that certain customers still prefer a touch probe. From there, once they have the alignment set, they can go back to the laser scanner and do all the rest of the inspection in a much quicker fashion.
And also, I guess we should point out that there are some things that scanners, laser scanners can't do that you still really need a touch probe, like deep, narrow holes and that sort of thing, right?
Absolutely. When it comes to an accessibility issue, nothing's going to be able to match a touch probe, especially if you have something like a 200, 300 millimeter extension to get inside of a feature. And then obviously certain types of materials, the laser scanner is going to struggle with. When it comes to glass, anything that's going to be transparent or translucent, even like certain types of plastics, the laser scanner is going to struggle. But something, and again, just looking at where the market has come and where the latest generations of scanners are at, when it comes to highly reflective materials, we've gotten to get much better with collecting data. Now, obviously, if it's a mirror type part or something that's purely made out of chrome, we're going to struggle with something like that. But I would say for the majority of materials that we'll customarily see, sheet metal components, even certain machined aluminums, we're able to gather data without much struggle at all.
Okay, now let's talk about the actual laser scanners for a bit. I mean, we are all probably familiar with the specs. You know, hundreds of thousands of points per second, captured. So I mean, in a few seconds or a few minutes, you can capture millions of points. But what does this mean in a practical sense? I mean, what are the advantages of being able to do that?
Well, there's a few key advantages. Obviously, the speed is first and foremost. I think that's why people want to look at laser scanning, being able to check more parts in a shorter amount of time. There's quite a few other corollary advantages that you can have with laser scanners, though. When it comes to being able to fixture and hold a part, the fact that with a laser scanner, you don't need to physically contact it means that your holding fixture can be much more simplistic. You're not having to worry about any tactile measurements moving the part as you're trying to inspect it, or somehow skewing your end results. Same goes true for certain types of material. Now, obviously, if it's something that's more fragile or prone to deforming under just even a light contact from a touch trigger probe, a laser scanner will instantly take care of any concerns with that because of not having to touch the part. And again, with the speed, the fact of that is we're collecting typically hundreds of millions of data points for a given part, but in a lot of cases, they're not points that would be normally checked with a touch probe. So when it comes down to it, and the analogy that we like to use is using a laser scanner is somewhat like using a paintbrush. We're going through creating a digital rendering of the part. So even if it's not something that the touch probe would physically contact, the laser scanner is going to pick it up. So it's almost like you get more bang for your buck with inspecting with a laser scanner.
So I'm assuming part of the advantage of that then is that there are features that you could qualify that would take a lot longer, or might even be almost impossible to do with a touch probe.
Absolutely. And the nice thing is with the laser scanner, if you're looking at just a specific feature, a very simple circle, and if you're going through and going to do some GD&T analysis off of that, the laser scanner is going to resolve that feature, that circle, by measuring thousands of points. With a touch probe, the speed is going to be a function of how many points that you want to measure. And then there's the trade-off between how many points that you want to measure to get a good, accurate understanding of the roundness of that feature or its true position, relative to how many points the laser scanner can give you in a fraction of the amount of time.
Okay. Well, we're going to have a webinar on this very topic next Tuesday. Mm-hmm. So if our viewers are interested in laser scanning, and we're going to have a webinar. It's called Increase Your Inspection Productivity with the Insight L100 laser scanner. Again, that's next Tuesday, September 1st, 2 p.m. Eastern, 11 a.m. Pacific. Alex is going to be the presenter, and I will be the host. So be sure to sign up for that. There should be a link in the story that is, we're linked to the story, but underneath the player page in there's a link to the webinar, and be sure to click on that and come out and learn some more about laser scanning, what it can do for you. Thanks, Alex, for joining us this morning. Thanks,
Mike. Thanks, Dirk. Thanks for having me. I appreciate it.
Sure, no problem.
Yep, we'll
see you Tuesday.
See you Tuesday. Thanks, Alex.
Bye, guys.
See ya. Yeah, and everyone out there, also remember, we send out e-blast on this, on our webinars as well, so you'll have an e-blast in your inbox probably Monday morning. So if you don't have a chance to get out to the article that Alex wrote and register there, you can register through the e-blast and check out that webinar. Going to be a good one. Going to be very technical, so if you're in that space, yeah, make sure you check it out. All right.